hydraulic washing or gravity separation. This is done for the ore like gold, silver, PT, PB, etc. Second one is the electromagnetic separation. It is useful for Fe2O3, chromite ore, pyrolusite ore, etc. Third one is the froth flotation. Froth flotation method. This method is useful for the sulfide ores and is PBS, ZNS, then Cu, Fe, S2, etc. are separated, are concentrated by froth flotation. Any sulfide ore is concentrated by froth flotation. And the fourth one is the leaching. Leaching. Treating the ore with some chemical to convert it into the soluble substance. So these are the four types of concentration that we are supposed to read. Out of these four, two are very important, and I have mentioned the strict sign here. Please do remember that these are often asked in the board examination, so it is very important for you read it thoroughly so that in board examination, if any question comes in part, you can attempt those questions successfully. So let us begin with the hydraulic washing or gravity separation. In case of native metals, this is based on the principle of difference in the densities of the impurity and the ore particle. As you know well that ores are heavier and impurities are lighter. So big lump particles are first grinded or crushed into the small pieces, then converted into the fine powder, and then that which is called pulverization. So pulverized ores are then fine powder of ore are then subjected to the gravity separation. Gravity separation can be done by two different ways, either by using Wilfley table or by hydraulic classifier. So this is the Wilfley table. This table is made up of wood. It has slant surface in which some wooden sticks are fixed. These sticks, wooden sticks, are termed as riffles, R-I-F-F-L-E, riffle. So these are riffles, and here water is allowed to run down from the top of the Wilfley table towards the down. So what happens when water comes in contact of this finely powdered ore? The heavy ore particles get settled down and the lighter gangue particles are flashed away or washed away. So here we collect a gangue. It is gangue plus water. So this is Wilfley table. Or we can do the gravity separation in the hydraulic classifier. See here, it has a big tank in which there is an arrangement of feeding the finely powdered ore. This is powdered ore which is added into this tank from through this device, and in this tank there is a water connection fitted at the bottom. So when first of all this is filled with the water and ore is poured or allowed to fed into this tank, and water is continuously floating, entering into this tank through the bottom supply pipeline. So what happens? Gangue particles or impurities being lighter, having less density, they are washed away through the upper outlet, and the heavy ore particles are settled down, and here the concentrated ores are collected. So this is the hydraulic classifier. This is reflectable. This is hydraulic classifier, and these two, either this or this, can be used for the gravity separation. Gravity separation. It is based that the heavier particles are attracted by the earth more powerfully than the lighter particles. So what will happen when the finely powdered ore put into the water, supply of water, what happens? The heavy ore gets wet, mass increases further, and so settle down. Here, within this wooden strips, the heavy ore particles are collected, and the fine impurities, lighter impurities, are flashed away or washed away. And this is the hydraulic classifier. From the bottom, there is an arrangement of continuous supply of water. From the top, water is fed into this tank. What happens when the finely powdered ore comes in contact of this? They get wet, and the heavier particles get settled down at the bottom, and the lighter gangue particles are flushed out from the top outlet, and the fine, heavy, concentrated ore particles are collected at the bottom. Second method of concentration is electromagnetic method. Electromagnetic method. This method is applicable for only those ores which are attracted, either the ore is attracted by the magnet or the impurities are attracted by the magnet. You see, it has two rollers which are connected by means of a conveyor belt. On this belt, ore is allowed to fall. This ore rolls on this bed, and the magnetic substance, either the impurity or the ore, whichever is the magnetic in nature, they will strongly attracted this because it is a strong magnet. This roller acts as a strong magnet, and this is non-magnetic roller. Non-magnetic. Magnetic. So what happens? The magnetic substance gets attracted by this magnetic roller, a strong magnetic roller, and it falls closer to the magnetic roller. So here we have, suppose ore is magnetic in nature, so ore will be get attracted here, and the impurities will be thrown away. So impurities or gangue is collected here, and ore is collected here. So this method he used for only in such cases in which either the ore is magnetic in nature or the impurities are magnetic in nature. And I have mentioned the example. For example, magnetite Fe3O4. In that case, we can use it. We can use it in case of chromite ore. We can use it in case of pyrolusite ore. So these are the substance: manganese, chromium, then iron. These are the substance which are strongly attracted by the magnet, and so for their concentration, electromagnetic method is very suitable. Third method, third method is called fourth flotation method. Third method is fourth flotation method. And the chemicals used in this method are: first one, chemicals used in fourth flotation methods are: first one is products, that are fine oil or eucalyptus oil. Second one is the collectors, sodium ethyl xanthates, CS3 xanthate, CS3, CH2, O, C double bond S, here S minus Na plus. It is hydrophilic and this ion is hydrophobic and phobic means repelling, hydrophobic and philic means loving. So this ion goes with the impurities. Impurities are attracted by this ion, and this ion attracts the O, attracted by O. Third one is stabilizer. Stabilizer. It is also used, stabilizers. And what are the stabilizers? Aniline. Then we have creosols. Do you know the formula of aniline? Aminobenzene. Aminobenzene is known as aniline. NH2. Aniline is the aminobenzene, and creosol, hydroxymethylated benzene, CS3OH. It is O-creosol. So it acts either this or this act as a fourth stabilizer. It makes the fourth stable. And the fourth one is the depressant. Depressants. Example, NaCl. In case O's contain two types of sulfide, as we see in case of zinc sulfide and PBS. So the galena is concentrated by fourth flotation method, but it contains as an impurity zinc sulfide also. So zinc is a metal, and with that associated is sulfur. Lead is also metal, it has associated with it is sulfur. So what to do when two sulfides, because if both the sulfide will form the fourth, in that case we will have problem thereafter during the conversion of metals ore into the crude metals. So it is the task for us to suppress one of the sulfide to form the fourth, and for that purpose NaCN is used. NaCN combines with zinc, forming sodium tetracyanide zinc. Yes, I know zinc. which is soluble, so it cannot form. When NaCN is used, the frothing of ZnS is suppressed and only fourth of lead sulfide will be collected. So these are the four reasons that is used in the fourth flotation method. So in fourth flotation method, what we see that this is the tank. In the middle of the tank, there is an agitator. Air. Here is the air, water, it is water. Here we will have froth,